Hello friends, it's MoNaCo here with almost our second to last video for the first unit, measuring matter, is what we're going to focus on today. You're going to know how to compare and contrast mass versus weight. They are not the same thing, and you'll know why. You also understand how to measure volume in two different ways, one of which you should know from geometry, the other which we'll go over a little bit today. Also, you're going to use the measurements of mass and volume to calculate an object's density using a standard formula. Density is one of those intensive physical properties that can be used to identify matter, so we want to go into investigate it a little bit. Okay, so how do we measure matter in science class? In chemistry, we measure matter three ways. We measure mass, we measure volume, and we measure length. Okay? Mass, we use a balance or a scale. We use a ruler to measure length, centimeters or meters. And for volume, we use graduated cylinders and other beakers with gradations on them to measure milliliters or liters. Okay? Sometimes you measure volume of an irregularly shaped object using displacement, which I'll go into details in a moment. So here we go. Let's compare and contrast mass versus weight. Mass is how much matter something has. Essentially, it's how much atoms it's got in it. Weight depends on gravity. They are both directly proportional. As mass increases, weight increases, but they are not the same thing. In chemistry, we really only work with mass, okay, on a balance. Now, everybody knows we have the same mass, whether we're on Earth or on the moon. However, the different force of gravity, it being weaker on the moon, makes us weigh less on the moon and more on Earth. If you're out in the middle of outer space, not on the moon, not on anything, there is practically no gravity, so you appear to be weightless, floating around. Your mass didn't actually change. You didn't lose any atoms. It's just that there's no gravity around to make you weigh something. Okay, so mass and weight are not the same, but they are directly proportional. Okay. Now, let's talk about measuring volume. It's the amount of space an object takes up. In liquids, we use a graduated cylinder. It's the big long glass tube with numbers along the sides. For regular solids, we're going to use that geometry formula, length times width times height. But for irregular solids, we're going to use this displacement method, which is illustrated to you below. In here, we've got some H2O, good old water, okay? And let's imagine that we started and the H2O level here was measured to be 100 milliliters. Okay? Well, as you can see, we've taken a key, an irregularly shaped object, and placed it into this graduated cylinder that had 100 milliliters of water in it. Common sense, just like when you get into the bathtub, the water level rises. Well, when you put the key into the graduated cylinder, the water level rises. This difference here means that this number shows up at a different spot. We didn't add any more water, so we know that the water didn't change. So whatever changed the volume in this graduated cylinder must have been the object that you put in there. So if we ended at 120 milliliters, the difference there is obviously 20 milliliters, and we can say that the key has a volume of 20 milliliters. That is the displacement technique. The key has displaced water. It's pushed it out of the way, causing it to rise in the tube. The number that it corresponds to also rises, and you can take the difference to figure out the volume of oddly shaped objects, like rocks or, well, keys. Now, density is a combination of mass and volume. It's the amount of mass in a given space. It's the ratio of mass to volume. And from table T, there is an equation. Density equals mass divided by volume. Question here that I'd like you to pause the video and answer is, which one of these boxes has a higher density? Which one of these boxes has a bigger ratio of mass to volume? You can see the volume is the same, but box A seems to have more particles in it. So decide, which one of these two boxes has the higher density? Which one has more mass in it per unit volume? The volume is the same. Which one would be heavier, have a greater mass, which has more matter in it? Okay. Okay, so now that you've kind of worked through that little question of the density there, let's look through a couple density problems. Get my scratch work out of the way, sorry about that. Well, density of water is a standard. It's 1 gram per milliliter. And there's some conversions. 1 milliliter equals 1 centimeter cubed here. We're not going to use that in those conversions, but that's something you just need to know. Question number 1. What's the density of an object with a mass of 60 grams and a volume of 2 centimeters cubed? Well, whenever you're asked a calculation question, you always have to start with your original equation. Then plug the variables that you know into it and solve for the missing variable. This is how algebra and chemistry are connected. So in this case, we know the mass is 60 grams and the volume is 2. So we know that the density, which is unknown at the moment, we could keep it as a D. Mass will be 60 grams. Volume will be 2 centimeters cubed. If you solve for that fraction, 60 divided by 2, you'll have your density. And the units of density are always grams per mil or grams per centimeter cubed. That's the equivalent units. For number 2, you're going to have a couple extra steps to solve here. You're given a gold brick that has regular dimensions. It looks like it's probably, you know, a rectangle of some sorts. All right? So you're going to have to first find its volume given length, width, height. So 1, you're going to have to apply the length times width times height formula equals the volume. Number 2, you're going to have to apply the density formula. Density equals mass divided by volume. See, I almost made a mistake there. Mass divided by volume. So whatever volume you get here gets plugged in over there, and they have given you the density. The mass, and they're asking the density. So you're going to solve the 2-step problem there. Please do so in your notes for the check. Next question. If a block of wood is a density of 6.6 grams per centimeter and a mass of 120 grams, what is its volume? In this case, we don't know the volume, but we do know the density and we do know the mass. There's no problem here. We always start D equals M over V, except this time we're actually putting in a number for D. And that number is 0.6 grams per centimeter cubed equals, mass is 120, so 120 grams over something. We don't know. Volume, so we can plug an X in there. And when you solve for X with your algebra, you will have the correct answer. Number 4 here is kind of similar in that we are asking what is the mass of the object. So what is the mass of an object if we know the volume and the density? So again, always start D equals M over V. You might want to try and be lazy, but there is only one good way to do this, and it's the right way. Slow and steady wins the race. So we know our density is 6.0 grams per centimeter cubed, and our mass is unknown, so we'll put an X in there, and the volume is 34 centimeters cubed. Again, use your algebra, solve for X, and you got your answer. Question number 5 is an awesome question. What's heavier, a ton of feathers or a ton of bowling balls? All right. So that rounds up this lesson. Now you should be able to understand how weight and mass are not the same thing. You understand there's 2 ways to measure volume, length times width times height for a regular object, and displacement for those funky, weird-shaped objects that don't have straight sides. You can use the object's mass and volume to calculate density. D equals M over V. And now you can use the object's density to find its mass or volume depending on what's missing, because it's, again, a straight plug and chug algebra question. So thanks for watching. Hope you had a good day.